So welcome to Belgrade.
Thank you so much. Pleasure to be here again.
Our first question is how would the world look like if there was no math?
Well, for me, it would be without joy. I mean, to me, mathematics, if done the right way, is poetry for the soul. So taking away some poetry from mankind just seems like a sad mistake. I think it would be a sad world. And of course, most people say, in a very practical sense, so much technology relies on mathematics, so probably technology goes down the wayside a little bit. But to me, it's more about the human spirit. I think it would be sad for the human spirit not to have mathematics in the world.
So, and why is that all the children perceive mathematics as the most difficult, if it's so joyful? Why is it always the most difficult subject in school?
I will tell you, I was one of those children. I did not enjoy mathematics in school at all. In fact, I even ran away from mathematics when I went to university, thinking it was the most joyless, boring subject there was. I turned out to be good at it, but I did not enjoy it one whit. And I think the problem is it's so easy to teach mathematics. It's all about computation and getting answers to questions with speed. And to me, that's not joyful. And in fact, even in the 21st century, it's unnecessary. It's not about getting answers anymore. If you want the answer to a problem, you pull out your smartphone and use this. That's what a 21st century person does. And kids can see that. So, if you're learning some algorithm that you have to do with pencil and paper in a very long, tedious way, why? I'm with the kids, why? However, if you teach with thinking, then that's a different story. And I wish we would teach the joy of the thinking behind the computations rather than just the computation. Because without context, without meaning, without the human brain being involved in the process, it's joyless, tedious, and hard. But if I'm interested, if I get curious, if I've got questions about it, and it's a conversation about mathematics, then even the hard work becomes doable and you're willing to do it. So that was not my experience, and that's why I became a mathematician, because I want to bring it back to the next generation.
But you're also involved in curriculum writing?
Absolutely, absolutely. So my career is somewhat strange. So I actually did fall in love with mathematics during my university years later, when I realized what mathematics was really about. It was all about why questions and what if questions, not like computation and so forth. And then I was a university professor for a while, and then I decided I wanted to go back to teaching. Then I became a high school teacher. So I did high school teaching for a while. So now I'm very familiar with the high school curriculum, at least in the US, and the university curriculum. And now I do a lot of work in both arenas, both at university level and high school level. I work with curriculum, I work with teachers, I give professional development, I go give talks to students, I give demonstration classes, and I come to fabulous places like Belgrade and talk about the joy of mathematics with fabulous people like Belgradians.
Thank you. So why do you love math? What is your reason? Is it because it's intuitive? What is the reason?
Why do I love mathematics? Well, I mean, as I said, to me it really is poetry to the soul. It really speaks to something that's beyond my humanness. I feel like mathematics is transcendental. I mean, we do, arithmetic in base 10 because we're human. We're obsessed with the number 10 because of our fingers. But I realize math doesn't care about our humanness. We could do mathematics in Martian, base 8 maybe, or base 13. There's something more to mathematics than the immediate that goes beyond me being a human being. And to me, that's fascinating and exciting and thrilling. I feel like mathematics is eternal. It lasts forever. And that speaks to something really powerful. I feel like I'm doing something deep. I feel like I'm connected to the universe. So yes, it's intuitive, it's hard, it's tricky. You have to think hard, I get that. But it's also so rewarding. It's when you have those moments of realization, you're just filled with wonder and joy and awe about the universe. So who can not be compelled by that? That's mathematics.
Can you please tell us something about one of your concepts or projects, Exploding Dots? What it is all about?
I'll gladly tell you about Exploding Dots. So one of my greatest joys and challenges being a high school teacher was how could I take this curriculum that was very rigid, very linear, no storyline, no context, and give it the human story. So I thought long and deep about various parts of the curriculum, algebra, some arithmetic, some geometry. And what I do is find a storyline that says, okay, what's really going on with arithmetic? And one storyline I came up with is this thing called Exploding Dots, which really starts at the very beginning. If we just understand how numbers work, we speak base 10, so we talk about ones and tens and hundreds and thousands. You can talk about any sorts of structure you like. And I realized if you think deeply about how we write numbers, then suddenly all those algorithms you learn in primary school, long addition, long multiplication, long division, which I was taught just to do without understanding, suddenly makes sense. You can just draw a picture, which I call the exploding dots picture, because these dots move like numbers in the system. You can just draw a picture and then you suddenly understand why long division works. And you can do that algorithm if you like, or not do it. Just draw a picture and see what the answer is going to be to 276 divided by 12. And then I realized, because mathematics doesn't care about us being human, you can do it in any base. So let's do it in an algebra class for high school, do it in base X, some unknown base. And then suddenly, all the work you do in high school algebra, all that advanced algebra, you realize is exactly the same work as you did in grade 5, just in base X rather than grade 5. So exploding dot suddenly makes that come true. But then it keeps going. And here's the wonderful thing about mathematics. The more deeply you think about something, the more and more it unfolds and unravels. So in this exploding dot story, then we just go, well, why stick with finite divisions? Why not do infinite ones? And suddenly we're in the world of calculus. And then why stop there? Why base 10? Why base 8? Why base 2? What if I did fractional bases or irrational number bases? And suddenly I'm in university level research work. So what I've done is I've taken this one simple kindergarten idea, how do you write numbers, and help students and help teachers think deeply and more deeply and more deeply, and you realize actually it is a story that goes from kindergarten all the way through primary school, all the way through high school, all the way through some university mathematics, even to some unsolved research problems today. So it's a truly mind-blowing story from very simple ideas, assume you know nothing, and just in an hour you can be doing really advanced mathematics with joy and pleasure and delight.
So what is your experience with Belgrade audience? Do they love math?
It's really interesting to me. I feel like something special is going on here. There seems to be a hunger for true, meaningful, joyous mathematics. So every time I've come to Belgrade, the audience I've worked with have been so appreciative of I was thinking about mathematics at a much deeper level. Unlike other places, I can go to other countries and I see, okay, people will applaud politely, but there seems to be a hunger for some real understanding of joyous mathematics in Belgrade. So there's something special here. So I feel like this is a very special place. And I hear that a lot of people still don't enjoy mathematics in school, so I feel like there must be a funny disconnect going on. A lot of kids go through schools here and just go through the grind of mathematics. Yet, somehow, the populace as a whole has this fascination for it at the same time. So I love that little paradox. So all we need to do now is turn that fascination into something that spreads all the way across, even into the school system. And I think Serbia's got something special going on. I think you're on the cusp of something brilliant about mathematics.
Okay, thank you very much.
My pleasure.